All right, this is the review sheet for the Unit 6 exam. This is our last unit exam before we start reviewing for the state test. So this is really important. Remember, the third marking period is a short one, so each grade counts more. So I'm going to do the entire thing. It's exactly what I taught you in class. I'm going to do it in the same methods. I'll show you multiple methods. No excuses this test. If you watch this video and you study, you should do fine. If you don't and you don't practice, you're going to be in trouble. So, number one, simplify. 6 to the 8th divided by 6 to the negative third. We are dealing with numbers that have exponents on them, the 8 and the negative 3, and they have the same base, the 6. So, for number one, we can use the quotient rule. Remember, quotient is the answer to a division problem. This is division, so the quotient rule. That states that when you're dividing numbers that have exponents in the same base, you subtract the exponents. So, 8 minus negative 3. 8 minus negative 3 is the same thing as 8 plus 3, which is obviously 11. So 6 to the 8th divided by 6 to the negative third is 6 to the 11th power. The mistake that a lot of you are going to make are you're going to write 6 to the 5th power, or you're going to write 6 to the negative 5th power. But you have to be careful. 8 minus negative 3. Keep change, 8 plus 3. 6 to the 11th power is the final answer. Number 2, which expression is equivalent to 8 to the 6 times 8 to the negative 4? Multiplication, we think of the product rule. We're multiplying two terms that have the same base, so we add the exponents. 6 plus negative 4 equals 2. If you see, I'm writing these equations, this one, 6 plus negative 4, on number 1 I wrote 8 minus negative 3. Whenever you're dealing with negative numbers, it might be a good idea to write this off to the side so that you don't make a mistake. If you don't write it off to the side and you try to visualize it in your head, you're going to make a mistake. 6 plus negative 4 is 2, so the answer is 8 to the second power, not 2, 8 squared, 8 to the second power. Number 3. Which expression is not equivalent to 5 to the 6th divided by 5 to the 10th? So not equivalent to. That means that just out of the 4 choices, one of them is not equivalent to this, and 3 of them are equivalent to it. So there's a few ways of doing it. I'm going to show you the very straightforward way first. I'm going to show you that 5 to the 6th divided by 5 to the 10th, that is the quotient rule again. So we do 6 minus 10, and that gives me negative 4. So 5 to the negative 4th. So 5 to the 6th divided by 5 to the 10th power equals 5 to the negative 4th. So A is incorrect, because that is 5 to the negative 4th. Then I can rewrite this. I can rewrite a negative exponent. I do the reciprocal, and I make it positive. So 1 over 5 to the 4th. So now I can cross that off. 5 to the 4th is 5 times 5 times 5 times 5 is 1 over 625. So choice D is incorrect, leaving us with 5 to the 4th, which is just a whole number, 625, which is not 5 to the negative 4th. So that's incorrect. The other thing I was going to show you for this type of question is that 3 of the choices are all exactly the same to each other. A is 5 to the negative 4th, is equal to C, which is 1 over 5 to the 4th, which is equal to D, which is 1 over 625. Since those are all equal to each other, they obviously can't be the correct answer. So the only one left is choice B. Number 4, which expression is equivalent to 6 to the negative 4th? All of that to the 5th power. So that is the power to a power rule. Power to a power rule tells us to keep the base and multiply the exponents. So that would be negative 4 times 5. So this answer is 6 to the negative 20th. But I can rewrite this. 6 to the negative 20th equals 1 over 6 to the positive 20th. Find the reciprocal, make the exponent positive. Number 5. The combined volume of all the tanks at an aquarium is 1.75 times 10 to the 5th gallons. The aquarium plans to install a new dolphin tank with a volume of 150,000 gallons. What will be the total volume of all the tanks at the aquarium after the new dolphin tank is installed? So 1.75 times 10 to the fifth is what it is right now. Then they're going to add another tank to it. So we need to add these two numbers together. However, one of the numbers is in scientific notation, and one of them is not. So there's two things we can do. We can either put both numbers into standard form and add them, and then convert it back to scientific notation, or we can convert 150,000 to scientific notation and then add them that way. I'm going to show you both methods. So 150,000 written in scientific notation is 1.5 times 10 to the fifth, because you have to move the decimal 1, 2, 3, 4, 5 times. And I want to add that to 1.75 times 10 to the fifth power. When you add in scientific notation, the first thing you have to do is check to see if the exponents are the same. They are both a 5, so we're good. So now I'm going to add the coefficients. 1.5 plus 1.75 is 3.25. Keep the exponent the same, and we're done. 3.25 times 10 to the fifth. The other way I said you could do it is by converting this number to standard form, which is 175,000, and add it to 150,000, and you'll see we'll get 325,000, which is 3.25 times 10 to the fifth. So either way you want to do it, fine by me. This will be a multiple choice question on the test, so multiple choice will probably be in scientific notation, so make sure we could convert it. Number 6, if the mass of a proton is 2.37 times 10 to the negative 14th gram, what is the mass of 50 protons? Well, if you know the mass of 1, then how do you find the mass of 50? What operation? Multiplication. If you have trouble with word problems because they're giving you the numbers in scientific notation, just think of the numbers in an easier form first. So if the mass of a proton is 2 grams, what's the mass of 50? Oh, obviously that's 100. You guys are really quick at that. So that tells me that I'm doing multiplication. So I need to do 2.37 times 10 to the negative 14 times 50. 50 doesn't have an exponent or a base attached to it. 50 is not written in scientific notation. However, we can convert it if we want to, or we can just multiply it exactly like it is. So I'm going to multiply 2.37 times 50, and that gives me 118.5. You're going to have to do that by hand, so make sure you can. I'm skipping that because I already did it by hand. You're going to have to. 118.5 times 10 to the negative 14. The 10 to the negative 14 stays the same. There's nothing for it to be multiplied by, so there's nothing to change it. In class, a lot of you changed it. You did 50 times 10 to the negative 14, right? We don't need to do that because we already did 50 times 2.37. So now we have this answer, 118.5 times 10 to the negative 14, but it's not in scientific notation. I need to move the decimal twice to the left, and we know our rules of LERD. If I move the decimal to the left, I have to move the exponent up. So 1.185 times 10 to the negative 12. If I take negative 14 and I'm picturing a number line in my head, or I'm even drawing it on my paper, if I go up 2 from negative 14, that brings me to negative 12, not negative 16. So you have to be very careful about that. Number 7, product of 4 times 10 to the 6th times 2 times 10 to the 3rd, really easy. Multiply the coefficients, get 8. Add the exponents, get 9. So 8 times 10 to the 9th, and that is the final answer. Not more I can do to help you there. That's pretty straightforward. The only thing I'll say is always make sure that your answer ends up in scientific notation. The number 8 is in between 1 and 10, so we're good. 5 to the 0 is equivalent to 1. Anything to the 0 power is equivalent to 1. Anything. Just make sure you know that. Simplify 1 over 5 to the negative third times 1 over 5 to the negative second. Two ways we can do this. The first way is to multiply it right as it is right now. Numerator times numerator, 1 times 1 equals 1. Denominator times denominator, 5 to the negative third times 5 to the negative second equals 5 to the negative fifth. But I can't leave my answer in the negative exponent, so I do the reciprocal and then make the exponent positive, 5 to the fifth power. The other way of doing this is by making these exponents positive first. So 1 over 5 to the negative third, find the reciprocal, make it positive, 5 to the third, same thing with the next one, times 5 squared equals 5 to the fifth power. Same answer. Number 10, what base and exponent can be substituted into the numerator to make the equation valid? Well, this is division because it's a fraction. So the quotient rule tells us to subtract the exponent. So what minus 3 gives me 4? And so if I want to write that out, what minus 3 equals 4? Add 3 to both sides. I know that that missing number is a 7. So the answer is 5 to the 7th power. So I really suggest writing down these separate equations on the side with the exponents. Number 11, a lab has 2 bacteria cultures. Culture A is 6 times 10 to the 6th, and culture B is 3 times 10 to the 5th. How do the 2 cultures compare? Right away I look and I see 6 divided by 3 and it says 2. So right away I'm thinking it's twice as many, but it's not. You have to be careful with those exponents. So if I was to divide these, 6 times 10 to the 6th power divided by 3 times 10 to the 5th power. That's how I'm going to compare them. The reason I'm dividing, I didn't just pull that out of nowhere, is because I looked at the 4 choices. Choice A, twice as many. Choice B, half as many. Choice C, 20 times as many. Choice D, 2 times as many. All of those are talking about how many times different size they are. So that tells me I need to divide them. So divide the coefficients, 6 divided by 3 equals 2. Subtract the exponent, so it's 2 times 10 to the first power. So if I was going to write that in standard form, that's 20, not 2. 2 times 10 to the first is 20. So culture A contains 20 times as many bacteria as culture B. So you got to be really careful. If I was going to expand those numbers out, it would be 6 and then 6 zeros, which is 6 million. And then 3 times 10 to the 5th is 300,000. So if I divide those two, we can start crossing off zeros, which you've learned to do since 4th grade. I can see that 60 divided by 3 is 20, not 2. So be very careful about that. All right, let's move on to the next page. Number 12 is a very straightforward multiplication question. 1.4 times 2.5. Got to do it by hand, unfortunately. So 1.4 times 2.5. 4 times 5 is 20. Put the 0 here. Bring the 2 to the next column. 1 times 5 is 5, plus 2 is 7. Add a 0, because we're going to multiply by the 2 now. 4 times 2 is 8. 1 times 2 is 2. Add these together. 0, 15, carry the 1, 3. 350. However, we have to look at the decimals. There's 2 numbers after the decimals, so I need to have 2 numbers after the decimal here, so I put it in between the 3 and the 5. So 1.4 times 2.5 is 3.5, and then I add the exponents times 10 to the 7th power, and I am done. So this is how you do it by hand. If you use the lattice method, you need to draw this box, and it is 14 times 25. 2 times 1 is 2. 2 times 4 is 8. 5 times 1 is 5. And 5 times 4 is 20. Count diagonally. 0, 8 plus 2 plus 5 is 15. Carry the 1. 1 plus 2 is 3. And that's it. 2 numbers after the decimal. 3.5. Number 13. A micron is a unit used to measure specimens viewed in a microscope, blah, blah, blah. Write this number in scientific notation. Count how many times you have to move the decimal to the right. 1, 2, 3, 4, 5. 4.237 times 10 to the negative fifth. When you have a really small decimal, your exponent is going to be negative. When you have a really big number, your exponent is going to be positive. So just be careful with that. If you move to the right, negative. If you move to the left, positive. Learned. X to the negative second, find the reciprocal. That would be 1 over x to the positive second. And that's it. That's all we're looking for. Nothing else we can do. And I can't remind you enough that x does not equal 1. There's an invisible 1 in front of the x, but x does not equal 1. But for this one, all we wanted was 1 over x squared. What is the quotient? Quotient means division. 4 times 10 to the 6, divided by 2 times 10 to the second. 4 divided by 2, divided by coefficients is 2. Subtract the exponents, times 10 to the 4th, and we're done. Super easy, super straightforward. Hopefully you guys can do that really quick, because that'll save you time with other questions. A music company sold 3 times 10 to the 6 copies of pop, and 6 times 10 to the 4th copies of rock. How many times greater? How many times greater? That tells me to divide. 3 times 10 to the 6th, divided by 6 times 10 to the 4th. You got to be careful. It says how many times greater is pop, so the pop music goes on top. Also, that's the bigger number because of the exponent. Exponent of 6, exponent of 4. That number is greater. Divide. 3 divided by 6, 0.5. Subtract the exponents, times 10 to the second. This is not in scientific notation. Move the decimal once to the right. Learn tells me if I move it to the right, the exponent goes down, so it's 5 times 10 to the first, which is 50 times greater. 5 times 10 to the first is 50. Number 17, which exponent would make the following true? So it's a power to a power rule. That means we're multiplying the exponent. So what times negative 6 equals 12? What goes in that question mark? The only thing that goes there, negative 2. Find the quotient. 2.5 divided by 5 is 0.5 times 10 to the negative 4th, because 3 minus 7 is negative 4. Move the decimal once to the right. 5 times 10 to the negative 5th. Since I moved the decimal to the right, I have to move the exponent down. 1 down from negative 4 is negative 5. Number 19. Determine the product. Again, 400.5. There's no times 10 attached to it. So we just do 400.5 times 3. And that gives me 1201.5. The exponent stays the same, so times 10 to the 5th. But that's not in scientific notation. Move the decimal 3 spots to the left. 1.2015 times 10 to the 8th. Since I moved the decimal 3 times to the left, the exponent goes 3 up. Number 20, public library has a length of 2 times 10 to the 4th millimeters and a width of 4 times 10 to the 6th millimeters. Obviously, that doesn't make sense. Oh no, it could with millimeters. I'm sorry, I take it back. What is the area in square millimeters? I think we're assuming that it's a rectangle. Area equals length times width. Area equals 2 times 10 to the 4th times 4 times 10 to the 6th. Multiply the coefficients. Area equals 8 times 10 to the 10th. Add the exponents. They wanted units, they wanted square millimeters. So all you really have to do is multiply. So super easy if you can interpret the question, which should have been pretty easy. Let's move on to the next page. Number 21. How many times larger is the radius of a silver atom, 1.5 times 10 to the negative 6, than the radius of a helium atom, 6 times 10 to the negative 10? How many times larger? Divide 1.5 times 10 to the negative 6 divided by 6 times 10 to the negative 10. 1.5 divided by 6 is 0.25. Negative 6 minus negative 10 is to the 4th. Put it in the correct scientific notation. 2.5 times 10 to the 3rd. 2.5 times 10 to the 3rd can be written as 2,500. 2,500 times larger. So practice that division. You need to divide by hand, you need to multiply by hand. The only way you're going to get it is by practicing. So in this question, I changed the first exponent to a 50 instead of a 60. They want to know the combined mass. Just ignore what they're calling them. It just says combined mass. So we're adding 3.72 times 10 to the 50th plus 5.24 times 10 to the 49. You are not allowed to add until they're the same exponent, so I leave the first one the same. The second one I can change. By moving the decimal one to the left, it'll become 0.524 times 10 to the 50th. Since I moved the decimal one to the left, the exponent went up to a 50. Add them together, 4.244 times 10 to the 50th. And that is the final answer. Add the coefficients, keep the exponents the same. All right, last page, number 23. Express that number in standard form, so move the decimal twice to the right, 340. How far will it travel in one day? One day is 24 hours, so I just need to do 3.4 times 10 to the second times 24. 3.4 times 24 is 81.6. Keep the exponent the same since nothing changed it. Move the decimal one to the left. 8.16 times 10 to the third. Or you could have done 340 times 24 and then convert your answer to scientific notation. Number 24, simplify using the laws of exponents. So the very first thing you need to do is get rid of those parentheses right there. 2 to the fourth to the second power is 2 to the 8th, because you have to multiply, times 2 to the negative 4th, divided by 2 times 2 to the 7th. In the denominator, when there's just a 2 there, that's really 2 to the first power. Make sure you know that. 2 to the 8th times 2 to the negative 4th, add them, 2 to the 4th. In the denominator, there's 2 to the 8th. 2 to the 4th divided by 2 to the 8th, 2 to the negative 4th. Need to make that a positive exponent. Do the reciprocal, 1 over 2 to the positive 4th. Watch this video, do extra practice, look them up on Google, look through the lessons again, do as much as you can. You need to be able to divide and multiply by hand. You need to know the laws of exponents. Study, it's the only way this is going to happen. If you're lazy, you're going to get a bad grade. Okay, good luck.